Hey, this is Mr. C, and thanks for tuning in to your next math lesson. This one's titled 4-7 Solving Inequalities. There will be two clue words today because this lesson is actually one part solving inequalities, and then we're going to get to graphing inequalities, but it's just all in the same lesson because this one won't take that long, the first part solving inequalities. And we're going to go on in 3, 2, 1. So let's just review how to substitute a variable. Let's look right here. So we want to substitute, wherever there's an x, we want to substitute 4. And we want to see if it makes this equation true or false. 4x minus 3 equals 13. Does it equal 13? Will it be true or false? So I know that wherever we have an x, I'm going to substitute 4. And I also know that whenever I substitute it, I put parentheses around it, which means to multiply. So now there's an x, now there's a 4. 4 times 4 minus 3. What do I do next? 4 times 4 is 16. Then I have the minus 3. Let's do that last step of 13. Because on this side, I did get 13, and this equals 13. Both sides are equal. Therefore, it is true. And that is the background skill that we need to be able to do in order to solve inequalities. Because this is being able to solve an equation, we need to be able to solve equations first, and then we'll move on to inequalities. All right, so just read this right here. Clue words are bacon McDouble. And continuing the review for the first section, well, what if it's false? Well, let's see. Let's try to solve the same equation, but let's put 5 in wherever there's an x. So here's the same equation, 4x minus 3 equals 13. But wherever there's an x, I'm actually going to see if 5 works. Well, I see right here that wherever the x was, we put 5. So it's 4 times 5 minus 3 equals 13. Next, I'm going to multiply 4 times 5, and I get 20 right here. Then I need to subtract 3. Well, that's very interesting, because 20 minus 3 is actually 17. And I'm looking, and the equation says 17 equals 13. Well, these numbers are not the same. Well, what does that mean? Well, that means that it's false. When we solved this equation with x equals 5, it did not come out evenly, since 17 does not equal 13. It would need to come out evenly, meaning 13 equals 13. That did not happen. Therefore, if we have a problem like that, and we say, does that make it true or false, we would say that it makes it false because they're not equal. Let's go. I see there's vocab notes up here, and let me just read this, and then I'll tell you what you're actually going to need to write. We are going to be looking at equations just like these, but instead of an equal sign, there will be a greater than or a less than symbol, and this would be a less than symbol, this would be a greater than symbol. And this is specifically called an inequality. Why is it called an inequality? Well, because today you're not going to see equal signs like this. You're going to see signs like this. And I know the inequality word, I know there's a prefix of in, and I know the prefix in means not equality. So I know that I'm not going to see the equal sign, and that makes it an inequality. So what parts are you actually going to write? You're going to write everything down below right here, including the two examples. Moving on in 3, 2, 1. All right, so here's this teacher example that I need to do because we just reviewed. So using x equals 4 is the following equation true or false? 10x minus 3 is greater than 14. So wherever there's an x, we're going to substitute 4. As I see up here, there was an x and we substituted 4. And notice we put parentheses around it, which is the correct way. 10 times 4 minus 3, let's see, that's 40 minus 3. And then when I do the rest of that, that's 37. And I have an answer here, and I'm going to read this. 37 is greater than 14. Well, I'm thinking, is that true? Is 37 greater than 14? That is true. And as you may realize, as we're getting to later on today, there's many numbers that I could put x in here to make this true. There are numbers I could put in for x that would make it false. But there's definitely more than one number because there's a lot of numbers bigger than 14. But this does make it true. So here's example 1. You know that I'm going to do example 1, and you're going to write it down. And example 2, you're going to attempt before I show you the answer. So let's go on example 1. I'm going to read the direction. Practice solving the following equations to see if they are true or false. Use x equals 5. So all we're writing is true, or we're writing false. So we're going to use x equals 5. And I'm going to zoom out here just a second so I have more space. Alright, so here we've gotten started on our problem. I got x equals 5 from over here, and I copied my problem from number 1. I substituted 5 in for where there was an x. And so now I have 8 times 5 plus 6. I'm seeing, is that less than 72? Well, 8 times 5, I know, is 40, and I'm going to copy the rest of my problem plus 6 and carry down my 72. 40 plus 6 is 46. And I'm asking myself, is that a lower number or less than 72? Yes, it is. Therefore, I'd write true. And let's see if I have. Therefore, yes, it is true. That is our answer. Make sure you also have the work that we have indicated right here. Let's zoom back in for example 2. So example 2, I see are two specific problems, number 2 and number 3. So please attempt number 2 and 3, writing them down with work in your notes, and come back for the answers. I'm going to talk about the answers in 3, 2, 1. All right, let's take a look at number 2 and what we should have had. Okay, so I have x equals 5, 4x minus 12 is greater than 15. I'm going to substitute 5 in for x. So now I have 4 times 5 minus 12 is greater than 15. 4 times 5 is 20. Carry down the minus 12 and carry down as well my greater than sign and 15. And next, I subtracted 8 is greater than 15. Is that true? That is false. Therefore, this problem should have false along with your work. Remember, if you have your work wrong, you should fix it in this stage as well. Let's look at the next number. Alright, so our next one is 3x minus 2 is less than 10. And I remember also that x for this does equal 5, and I substituted it with parentheses. So now I have 3 times 5 minus 2 is less than 10. 3 times 5 is 15, and I carried down the minus 2 and carried down the rest of our problem. Then I need to subtract 15 minus 2, and I get 13. Is 13 less than 10? No, it is not. Therefore, this problem is false. And I'm going to move on to the next slide in 2, 1. All right, so here's your independent practice problems. As you notice, I'm trying to be gentle on this. There's only 2. We also have graphing inequalities next. So once you're ready for the answers, unpause the video in 3, 2, 1. Here are your problems, answers with the work. And now we're going to move on in 3, 2, 1. All right, so we're on to a new section, 4-7 graphing inequalities, but they are still related and counted as one lesson because they're about inequalities. Write this at the top of the next page that you have in your notebook. Moving on in 3, 2, 1. All right, so here's my teacher example. And remember, there is another clue word in this video if you're choosing to watch this. We can also graph inequalities on a number line. This is a number line. Notice how there's numbers and it's in a straight line. The numbers are evenly spread apart. When we do this, we put either a closed or open circle around a number and draw an arrow in one direction. So this arrow actually represents x is less than 3. So they have an open circle here and they have an arrow going to the left, and we're going to analyze exactly why that is right now. There's an open circle because the answer for anything here cannot include 3. What do I mean by that? Well, if I wrote x equals 3, and then I put 3 in for x, would that make the equation true? Is 3 less than 3? Well, that's not true. Therefore, we cannot include 3 in this equation. But anything less than 3 can be included in the equation. So whenever there's a circle on a number, that means that you cannot include it. let's go on to the vocab note. Here are your vocab notes, and I want to talk specifically about what I have written down here: empty bag of chips and full bag of chips. So, an open circle, such as indicated here, means that number is not included. And I want you to notice how that would use signs that do not have a line underneath them. And we'll talk about how we will read that in the future. So this would be x is less than 2. If there's no line underneath it, that number is not included. X is less than 2. I need to put a circle on 2 that's not filled in, meaning it doesn't include that. I like to think of this circle as an empty bag of chips. When you reach in that bag, you are quite upset and there's nothing in it. Therefore, I want to make sure that that number is not included. If it's empty, there's no 2 in there. Meanwhile, over here, this is a full dot. That's a full bag of chips. You know, we love a fresh new bag of chips. If you put a full bag of chips on a number, it means that does include it. And it's filling up that bag. Meanwhile, there's nothing in this bag. The 2's not in the bag. It's not filling it up. So if there's a closed circle, the number is included, and I read this as less than or equal to or greater than or equal to. X is less than or equal to 2. And we're moving on to our examples in 3, 2, and the clue word is pumpkin patch. Moving on. So here's example 1, and we're going to try to graph x is greater than 5 on a number line as shown to you before. But my question is, how do I know where to start the number line? Well, if I'm asked to graph this right here, I know that it's going to be on a number line. Mr. C, so you said a number line, so I'm getting started. I'm making this. I know I got to make a line, so there's the line. Well, Mr. C, what numbers do I put on this line? Well, a good rule of thumb is I want you to look what number is in the equation. X is greater than 5. And you could just go ahead and put that number near the middle here. Let's just say that we're going to put it 5 right there. And I know that numbers go up this way and numbers go down this way. So I have my numbers, and I know that I'm going to put a closed or open circle on this 5. Well, if you look in the previous one, I know that this does not have a line underneath it. Therefore, this is an open bag of chips. It does not include 5 as a possible answer that could make this true. So I'm going to put an open circle here. So then the next question I have is, which way does the line go? Okay, so I'm reading x is greater than 5. Okay, any number that's greater than 5. I'm looking here, which numbers are bigger than 5? Okay, the numbers to the right are bigger than 5. And so I like to grab a marker or a highlighter, and then I would highlight that side of it, and I would use something different than a pencil so that it's obvious. Now here's some things just repeating what I said before. Let's talk about when there may be a closed circle around the number. Notice we're still on example 1. Okay, so sometimes our inequalities have a symbol like this, which is read as is less than or equal to, or is greater than or equal to. This symbol under the inequality means, just like I said, and specifically what part of that means equal to. Well, I see that when there's a line underneath it, then I read it is equal to or equal to. If we want to graph an inequality like this, we use a closed circle around the number because that number can be included in the group of numbers our variable can be. For example, we have x is greater than or equal to 8. So here's our answer for x is greater than or equal to 8. And because I know this is example 1, this should be written in your notes, and now I'm going to explain it. Well, I see that is or is equal to, and I know this is a full bag of chips. Therefore, it does include 8 in it. The bag is full. And I'm wondering, why is the arrow going to the right? Well, x is greater than or equal to. This stands for greater than. All the numbers bigger than 8 do make this equation true. So for example, I see right here, Mr. C, you're telling me that 9 would make this equation true because it's shading it in with the arrow. So let's say I did put 9 in for x. Is it true? Well, 9 is greater than or equal to 8. So yes, it does make it true. Anything bigger than 8 or at 8 will make this true. Moving on in 3, 2, 1. So here's example 2. We're going to practice graphing the following inequalities on a number line. As you try these, remember, you start by drawing a line, and then you make some more lines, and you put the number that is listed right in the middle. Ask yourself these questions while you do them. Is this going to be an open circle or a closed circle on the number? In which way will the arrow point? Please do these problems and come back for the answers in 3, 2, 1. Okay, so here are your answers. I notice this is an open circle because this is less than. There is no line underneath it. Therefore, this is an open bag of chips. It does not involve 10. It's empty. This is a full bag of chips because it has a line underneath it right here, or equal to. Therefore, it does include 7. That makes this equation true. There's no line, therefore it's open. There is a line, therefore it's closed. X is less than or equal to 6. Any number less than 6. Here's your independent practice. Come back for the answers. I'm going to show you them in 3, 2, 1. Here are your answers for independent practice. I really do hope you enjoyed watching this video, and after you get to choose whether you'd like to do these things. We don't have a group math game today, but you can choose Khan Academy or making a math video of this section using Explain Everything and upload it to the team drive. And remember, make sure that you do upload it to the team drive. And if you don't remember, you are awesome. I really hope you learned something.